I knew something was wrong with 3IATLAS the moment the trajectory collapsed under its own assumptions. Every model we trusted, Newtonian, relativistic, perturbative, fell apart the instant the object crossed Saturn's orbit and its radial velocity data began slipping out of alignment. I am not speaking about noise or calibration issues. I am speaking about a systematic deviation that behaved like intention. A hyperbolic visitor should accelerate away, pushed gently by solar radiation pressure, and freed forever from our star. But instead, Atlas began slowing down, as though responding to a command embedded inside its own structure. And that is why I am speaking today, not to reassure you, but to tell you that the cosmos has just presented us with a riddle masked as a returning object. When the team at ISARP sent me the corrected velocity curve, the drop was unmistakable. A clean inflection at the heliosheath. A clean refusal to behave like a comet, asteroid, or fragment of anything that should obey passive celestial mechanics. Something exerted a counterforce on Atlas, 10 times stronger than any plausible outgassing estimate, yet silent, invisible, and precisely modulated. JWST confirmed the anomaly with infrared imaging, a faint emission line emerging only during deceleration, as though a dormant system awakened at the threshold of interstellar space. I stared at that spectrum for hours. It did not match water, CO2, silicates, carbon chains, or any catalog superheated dust signature. Instead, it resembled radiative leakage from unstable superheavy matter, something no natural object should contain, let alone activate. That was the moment I realized we might be witnessing a programmed maneuver. The orbital recalculation arrived next. What was once hyperbolic flattened, bent, then curved inward like a hand turning back toward its origin. If nothing else changes, the object will complete its turnaround around 2045 and begin drifting back toward the sun with the slow persistence of something that is pacing itself. We named this phenomenon the 3I interstellar recurrence cycle because science requires terminology even when it trembles at the implications. Recurrence means repetition. Repetition implies a purpose, and a purpose implies, at the very least, a system capable of remembering its path. I want you to understand the severity of what we are seeing. To force an interstellar object onto a bound orbit requires energy. Not passive friction, not random collisions, but directed energy, applied deliberately or by a mechanism capable of adjusting itself over decades. When we looked deeper into the infrared emission, we noticed the signal was pulsed. Not regularly, not like a beacon, but modulated in short bursts separated by intervals that did not match thermal relaxation or material shedding. It behaved like a pattern, faint, incomplete, but patterned. And that is where the real mystery begins. Because when we transformed the emission variability into a frequency map, we found repetitions that mirrored ratios seen in information systems, entropy dips where noise should dominate, discrete jumps where smooth curves should exist. It was as if Atlas was not just slowing down but communicating something about the process, or about itself, or about its destination. I am not saying it is a message, not yet, but I am saying it resembles one. Enough to make every physicist in my group sit back in their chair and stop speaking mid-sentence. Even more unsettling, the spectral anomaly appeared only after the deceleration began, as if the object withheld this signature until the moment its trajectory demanded a justification. I have spent my career arguing for the possibility of extrasolar intelligence, not because I seek drama, but because nature often whispers before it speaks. Atlas, however, is not whispering. It is revealing a half-finished sentence and daring us to interpret the missing words. Some members of the team think the object is executing a survey loop. Come in, gather data, leave, return, compare, a cyclical reconnaissance pattern spanning centuries. But that theory fails to answer the most important question. Why activate the anomalous emission now? Why only during the braking phase? Why pulse the pattern at ratios that mimic encoded structure? The closer we analyze Atlas, the more the data behaves like intention wrapped in physics we do not yet understand. And there is something else, something we have not spoken publicly about. In the last dataset, hidden beneath the emission fluctuations, there is a secondary modulation that does not match any known natural process. When I saw it, I felt, against every instinct of scientific restraint, that the object was trying to convey something more than thrust, more than deceleration, more than a mechanical cycle. But I will not reveal that pattern now, not yet, because before I show you what we found, you need to understand the full magnitude of the turnaround that is coming, and you need to see the evidence for yourself before you hear what that hidden signal might actually mean. The deceleration of 3I/ATLAS became undeniable when Voyager 2's plasma wave instrument captured an abrupt shift in the heliosheath environment, an echo of something pressing back against the solar wind. I reviewed the cross-referenced data myself, frame by frame, until the numbers stopped feeling like physics and started feeling like intent. A natural object entering the heliopause should behave predictably. Slow changes in pressure, gradual transitions, nothing more dramatic than the steady retreat into interstellar space. But ATLAS did not retreat. It resisted. And resistance implies either an active mechanism or a phenomenon we have never catalogued in the long history of celestial dynamics. When JWST confirmed the drop in outward velocity, far sharper than anything radiation pressure could produce, I realized we were facing the first interstellar object that refused its assigned destiny. A hyperbolic escape path is a one-way road. Once you exit the sun's gravitational well, nothing short of propulsion can pull you back. Yet here we were, watching a visitor from another star behave as though it carried a memory of where it came from and where it intended to go. Attempts to explain the deceleration through traditional astrophysics failed with astonishing consistency. Solar wind drag, insufficient by at least an order of magnitude. Micrometeorite collisions, too random to produce such a smooth curve. Outgassing, no thermal spikes, no jets, no dust plume. Even exotic hypotheses like interstellar dust resistance collapsed as soon as we applied realistic density distributions. Nature does not engineer such precision. It improvises, it fluctuates, it resists order. But the curve we observed was orderly to the point of discomfort, like a braking maneuver designed to achieve a predefined orbital capture. I presented the findings to a closed panel of colleagues, many of whom stared at the graphs as if they were watching a law of nature bend in real time. The room remained silent for longer than I expected. Then one of the senior dynamicists whispered, "It's coming back." Not metaphorically, not poetically, but literally curving inward, reshaping its trajectory under a force that obeyed neither chance nor chaos. It was after that meeting that the term 3I interstellar recurrence cycle emerged, not as a conclusion, but as a placeholder for an event without precedent. For ATLAS to slow this much at the heliopause, it would need a sustained counterforce. And the infrared data gave us the first hint of what that force might be. The anomalous emission line blinking awake at the exact moment the deceleration exceeded threshold. Coincidence does not synchronize itself so neatly with a dynamical anomaly. Something inside ATLAS switched on. Voyager's magnetometer soon confirmed a subtle distortion in the local field, nothing dramatic but consistent with a non-symmetric thrust pattern. A natural outgassing plume should spin, jitter, rotate irregularly. But the field signature was too clean, too stable, as if a propulsion method was firing in pulses too faint for us to detect directly. That alone would have been enough to raise alarms. But then came the most unsettling revelation. The new orbital solutions no longer predicted escape. They predicted return. The curve flattened into a long stretched ellipse, barely bound, but bound nonetheless. A returning interstellar object is not just a physical anomaly. It is a statement, a declaration that something about the initial pass, our star, our planets, our environment, warranted a second look. For some, this was an astronomical curiosity. For me, it was a message written in orbital mechanics. I am not finished here. As we refined the trajectory, a disturbing pattern emerged. The braking phase correlated with the faint pulsations in the infrared spectrum, suggesting the deceleration was not merely mechanical but orchestrated. The pulsed emission resembled a countdown, a sequence, an algorithm adjusting in real time to meet a desired orbital endpoint. And then, buried beneath the noise floor, we detected a secondary modulation, so faint that even calling it a signal felt premature, but it behaved too intelligently to ignore. I cannot reveal its structure yet, not until I explain the mechanism we believe triggered it, and the deeper anomaly hidden in the spectral signature that followed. Because the deceleration was not the end of the mystery, it was the invitation. The turnaround was the moment every assumption we carried about interstellar objects collapsed under its own weight. When NASA's N-body simulations, ISARP's reinforced models, and my own independent calculations all converged on the same impossible conclusion, I felt a sensation I have only experienced a few times in my career, a quiet, heavy recognition that the universe had just broken character. Objects like 3IATLAS do not stop, they do not pause, and they certainly do not reverse course with the grace of something following instructions written long before it ever entered our system. Yet the orbital plots told one story with brutal clarity. By 2045, Atlas will ease into a full turnaround arc and begin drifting back toward the inner solar system as though following a breadcrumb trail of its own previous trajectory. The recurrence was too exact to dismiss, too deliberate to attribute to chaos. The models layered on top of each other like translucent sheets, revealing a path so precise that only a guiding mechanism could produce it. And this is when the question stopped being, what is happening? And became who or what planned it. Some of my colleagues resisted that shift. Others embraced it with a kind of feverish curiosity. But I focused on the data. The pulsed infrared emissions that synchronized with the braking phase did not disappear. Instead, they evolved. The waveform became sharper, the peaks cleaner, as if the deceleration was only the first activation point. Once the object stabilized on its inbound path, the pulses changed rhythm like a device transitioning from one mode to another. I spent nights feeding the new waveform into every analytical tool available, Fourier transforms, entropy mapping, statistical modeling, and the pattern resisted randomness with remarkable stubbornness, not noise, not thermal dissipation, not venting, something structured, something that behaved like a system running code. It was around this time that members of the model breaker circle, those unafraid to hypothesize beyond the traditional boundaries, brought forward the theory that ATLAS might be self-regulating. Not alive, not conscious in the biological sense, but engineered to adjust its own orbit using internal energy sources we do not yet understand. The theory split into two branches. The first proposed that ATLAS is a self-regulating structure, an autonomous construct designed to maintain a long-term survey cycle between star systems. In this model, the object is not a probe in the sense of a vehicle, but a mechanism, part detector, part recorder, part archivist, using exotic matter or an unfamiliar energy reservoir to maneuver across centuries. The second theory was more radical, that ATLAS is a programmed probe, executing a looped trajectory written into its design: approach, observe, depart, return. A reconnaissance cycle, perhaps spanning hundreds of years, intended to measure not environment, but change, to compare one epoch against another, to watch for development, anomalies, or signals worth responding to. Both theories terrified and fascinated me equally, but what pushed me toward accepting the possibility of programming was a subtle feature we discovered in the trajectory reconstruction. The turnaround arc is not merely gravitational, it anticipates perturbations. Jupiter's shifting position, solar cycle fluctuations, even predicted density pockets in the interstellar medium. As if the path was not just reactive, but planned, as if the object expected to return and charted a route optimized over centuries. Then came the most unsettling clue, the change in the infrared modulation after the turnaround projection. The pulses no longer correlated solely with thrust-like behavior. They began clustering into sequences separated by quiet intervals too uniform to be random thermal cooling. When we isolated these clusters, we found repeating structures, but incomplete, as though fragments of a larger expression. I remember staring at the screen, feeling something tighten in my chest, because for the first time it looked like ATLAS wasn't just adjusting itself. It was beginning a different phase, one that resembled output rather than maneuver, a pattern that might be a form of communication, but truncated, as if waiting for the right moment to speak fully. I will not describe the structure of that sequence yet, not until we examine what the spectral signature reveals about the internal mechanism that triggered it. Because the turnaround was not simply a change in direction, it was the beginning of a message. And we have only heard the first syllable. The spectral data arrived in scattered batches, JWST exposures, ground-based infrared composites, radio backscatter from Voyager, and yet every dataset, regardless of origin, converged on the same anomaly. The surface of 3IATLAS emitted a signature that did not belong to any natural catalog, not cometary volatiles, not carbonaceous dust, not even the exotic silicates sometimes found in interstellar grains. Instead, it radiated in frequencies associated with unstable, super-heavy elements, materials that should decay almost instantly, yet here they were, pulsing in rhythmic bursts, synchronized with ATLAS's deceleration. When I filtered the signal further, something astonishing emerged. The emission surged only during periods that corresponded to active maneuvering. The spectrum dimmed when ATLAS drifted, brightened when ATLAS corrected. It was as if the object carried an internal engine not designed for propulsion alone, but for communication through its own waste heat. A mechanism that revealed itself not in visible light, but in the ghostly glow of the infrared, where entropy becomes the handwriting of hidden technologies. In the leaked classified report was the tipping point. It referenced a propulsion concept I had only seen in speculative papers, the idea of non-symmetrical thrust driven by asymmetrically decaying exotic matter. According to the report, the pattern in ATLAS's emission matched predictions from models involving directional energy release. That would explain the clean braking curve, the absence of visible jets, and the subtle electromagnetic signature Voyager captured. It would also mean that ATLAS was not merely reacting to forces, it was generating them. I ran the numbers again, searching for natural mechanisms, searching for ways to disprove the implications staring back at me. Every calculation collapsed. Every model failed. Nothing in known astrophysics produces a thrust signature like this without deliberate engineering. And so I was forced to entertain a possibility I had spent my career preparing the world to consider. A TLAS might be an artifact. But something more troubling lay beneath the primary emission, a secondary, quieter modulation, so soft it almost drowned in the background noise, began to reveal a structure. At first it looked like a thermal flickering, a harmless glitch in the data. But when I analyzed the timing, the ratio between pulses, the recurrence intervals, it became clear that the modulation behaved with intention. It was too ordered, too persistent, too carefully spaced to be an accident. The entropy curve dipped at precise intervals, as if information was woven directly into the heat signature. I stared at the sequence and realized it echoed something from earlier, those incomplete clusters we detected during the turnaround phase. The same fractured cadence, the same deliberate spacing, the same sense that the object was trying to express something but withholding the full message until a condition was met. The discovery left me with a deeply unsettling realization. The spectral signature is not just evidence of propulsion or composition. It may be the first physical proof of the programming hypothesis, a controlled system activating in phases. Maneuver first, signal second, purpose revealed last. But I cannot yet show you the pattern hidden within the modulation. Before I reveal that, you need to understand the final implication of the recurrent cycle and the future it demands of us. Because the message is not confined to what ATLAS emits now. It extends to what it intends to do next. As soon as the trajectory stabilized and the spectral data aligned with the internal modulation, the final implication became unavoidable. 3IATLAS was preparing for its next return long before we ever noticed its first anomaly. The recurrent cycle was not an accident of gravity or a quirk of material physics. It was a design, a loop written into the behavior of an object that re-enters star systems not out of gravitational obligation, but out of purpose. And when we projected Atlas's inbound path to its next closest approach, somewhere around the year 2150, the cycle revealed a rhythm measured not in decades, but in centuries. The question that mattered most was never how Atlas slowed down. It was why it intends to come back. Astronomers began to frame the event not as a visitation, but as the beginning of a new scientific field, recurrent interstellar astronomy, a discipline built on the premise that some objects do not pass through star systems only once. They return, compare, record, update. They watch for something, they wait for something, or they respond to something. I could no longer ignore what the secondary modulation in the infrared signal suggested. When reconstructed across multiple datasets, the fractured clusters began forming a scaffold. The entropy dips aligned with a structure too intentional to dismiss. It resembled the early drafts of a message, compressed, incomplete, like shorthand for an idea the object was not yet ready to express. A preface, not a conclusion. The most unsettling discovery came when we compared the modulation pattern to historical solar data. The infrared clusters appeared to sync loosely with long-term solar cycle projections, as if Atlas anticipated the star's future state. Its next return occurs during a predicted period of solar stability, ideal for high-fidelity measurement, long-duration proximity, or contact. I wish I could claim certainty about the message embedded in its spectral pulse, but the truth is that we have only decoded the edges of it, a framework, a rhythm, a structure without content, as if the object is telling us it will reveal the rest only when it arrives. And that realization changes everything about how humanity must respond. We face a decision now. Wait for Atlas to complete its cycle, or send a probe, something engineered with the intention of intercepting it, observing it, or listening to it more closely than we can from here. A mission that anticipates its return instead of reacting to it. But there is a final detail I withheld until now. When we overlapped the incomplete modulation sequences from each observation period, heliopause, deceleration, turnaround, an alignment emerged. 3 fragments, each from a different phase of the cycle, each separated by decades, each carrying a portion of a larger expression. When combined, the pattern formed a coherent beginning. Only a beginning, but unmistakably deliberate. A seed of information waiting for the rest of its sequence. It felt less like a message and more like an announcement, a quiet declaration that the object is not finished communicating, that its next return will not simply be another pass, but the continuation of a statement interrupted by distance and time. And so I end with the only truth the data allows. 3IATLAS is coming back because it intends to, and whatever it began telling us in heat and motion, it will finish when it returns.